Okay, problem 65. Poof. 3 times 4, x minus 5 minus 4, 2x plus 1 equals 5. Wow, that is, that's a killer. That is a killer. I just want to erase this because it's really bugging me. All right. So, what they're trying to make you practice is the distributive property. Anytime you see something multiplied by a brackets with a plus or minus sign, with a 4x or a 2x or anything with x in it, they want you to practice the distributive property. That's what they really want you to do. Now, it would be so much easier if it were 3 times 4x minus 5x, because then we do 3 times minus x, right? 4x minus 5x equals minus 1x. It would be so easy, and the answer would be negative 3x. But they do it this way to make us work. And it will be useful in future math. Not very useful in everyday math, but nevertheless relevant to know, because you're going to be practicing the fundamental basics of algebra. This is what algebra is. This is finding what x means, finding what the variable is. So let's do this thoughtfully, step by step. First, we're going to multiply these buggers and these buggers. Notice how you can multiply things. You know, when you're multiplying, it doesn't matter if they're like or unlike terms. It doesn't really matter. But when you're adding or subtracting, it's really important. That's why we're kind of like blocked here, but we're not blocked here. We use the distributive property to use multiplication to just get this done. Okay, let's do this. 3 times 4 times x. 3 times 4 times x, right? 3 times 4 times x. That's 12x. 3 times negative 5 is minus 15. Done. We look to the left of the number to find the sign. We have it. That's a negative 4. We have negative 4 times 2x, and then negative 4 times positive 1, or just 1. Minus 4. This is really minus 4 times 2 times x. Minus 4 times 2 is minus 8 times x. That's minus 8x. Minus 8x. Minus 4 times positive 1 equals minus 4 equals 5. We've got the first line done. That was the killer. If you got here, you're going to be okay the rest of the way, because then we just combine like terms. Here are like terms here. Here are like terms here, and here also. So the like terms in this case is 12x and minus 8x. And the other like terms is minus 15, minus 4, and 5. Let's do it. 12x minus 8x equals 4x. That's done. Minus 15 minus 4 equals minus 19. That's done. We go to the other side of the equation. We just drop the 5. Can you guess what the next step is? We got to get rid of this bugger here. We got to put this over here because we want one side to have the x's and the other side not. So, how do we get rid of the minus 19? We add 19 to both sides. This cancels out. 4x equals 5 plus 19 equals 24. Now what do? We got to get rid of this 4 here. We want to know what this side is equal to x. But now it's equal to 4x, so we can't do it. 4x is really 4 times x. We started with x, we multiplied by 4 to get 4 times x, or 4x. We divide the 4x to get back to x. That's a lot of use of the word x in one sentence. So this cancels out, we're left with x. 24 divided by 4 equals 6, and that is our answer. Moving along. This leads to a 5-step process to solve any linear equation. While all 5 steps aren't needed, they can serve as a guide. So they have this little guide here. You can read that. what they're saying basically is to distribute first and to do everything the same as you've been doing before. The order of these steps is very important. World view note. The Chinese developed a method for solving equations that involve finding each digit one at a time about 2,000 years ago. We can see each of the above 5 steps worked out in our next example. All right, how many examples do they have left? Quite a few. All right. Well, let's look at these steps. Distribute through any parentheses if necessary. Combine like terms on each side of the equation. Get the variables on one side or the x on one side by adding or subtracting. Solve the remaining 2-step equation. Add or subtract, then multiply or divide. That sounds very confusing to me. We'll look at it. Check your answer by plugging it back in for x to find a true statement. That is very clever. If you're not sure if you got the right answer, that's a great way to check. You just plug the number that the solution into the equation. It should work out. Let's do that. All right. So we got example 66. 4 times 2x minus 6 plus 9 equals 3x minus 7 plus 8x. Once again, this looks like a mess. Did I put it up? Did I over bracket? I think I did. That's gone. All right. So the first thing we're going to worry about is this bugger right here and this bugger right here. Why? Because first we'd have to do the brackets. If we remember the first part, we always do the brackets first. And we always try to solve what's in the brackets first. Can we solve what's in the brackets here? We can't subtract unlike terms. 2x has an x at the end of it, and minus 6 doesn't. So we can't do anything with that. So we work our way around that by doing the distributive property. All right. My voice is getting sore. I don't know how teachers do it for 2 hours. 4 times 2x really means 4 times 2 times x. That equals 8x. All right. 4 times, look at the sign to the left of the number. 4 times negative 6. 4 times negative 6 equals minus 24. We bring this down. Plus 9 equals. We're doing it again. Look inside these brackets. X minus 7. We can't solve that. So we use the distributive property to get around it. 3 times x equals 3x. 3 times, look at the sign to the left of the number. 3 times negative 7 equals minus 21. And plus 8x. Can't do anything with that. And now we combine like terms, right? So like here we got x all alone, so we don't touch that. Here we have 2 numbers, we can do that. Minus 24 plus 9 equals minus 15 equals. Here I have 1 number, it's all alone, and here I have an x and I have an x, so I can combine these. 3x plus 8x equals 11x minus 21. Now I want to get everything to one side, right? Now the book says get rid of the smaller x, you'll avoid having a negative. I agree. So, or what they call that is a negative coefficient. A coefficient is the number to the left of the it's like this number right here. This is the coefficient. All right, it's the coefficient of x. Let's erase that. Goodbye. Goodbye, scribble. All right. So this is the smaller number between 8x and 11x. So what we're going to do is going to subtract 8x from one side and 8x minus 8x on the other. So 8x minus 8x equals 0. Minus 15 carries over. Equals 11x minus 8x equals 3x. And the minus 21 carries over. Now we have minus 15 equals 3x minus 21. We want to get what we know on one side and what we don't know on the other side. We don't know what 3x is. We want to get rid of this minus 21. We add 21. Boom, that's gone. It's disappeared. It's out of here. Minus 15 plus 21. Think about it. That's 6. And now we're left with 6 equals 3x. We divide by 3, right? If we have 3 times x, we divide by 3 to get back to x, and we divide the other side by 3 also. We have x equals 2, right? Because this cancels. 6 divided by 3 equals 2. Good job, good job. That's what we do. So now we have our answer. We can check to see if this works. So let's pin that to the back of our brain. We know x equals 2. Let's redo it. Let's redo 66. All right? So 66, x equals 2. I'm going to write it right here. 4 times 2x minus 6 plus 9 equals 3x minus 7 plus 8x. We know what x is. We solve for it. It's 2. Let's put it here. 4, 2 times 2 minus 6. Let's put this in brackets to remind us we have to do the multiplication first in these brackets. Plus 9 equals 3 times 2 minus 7 plus 8x. Now let's do the brackets. 4, little brackets. 4 minus 6, right? 2 times 2 equals 4. Minus 6 plus 9 equals 3. 2 minus 7 equals minus 5 plus 8. Oh, wait a minute. 8x here. That's a 2, right? I have to add the 2 here. Sorry. I don't know why I'm putting these brackets here. Let's solve this. 4 minus 2 minus 6 equals minus 2. 4 times plus 9 equals 3 times minus 5, that's minus 15, plus 8 times 2, that's 16. Let's see what this comes out to. Minus 8 plus 9 equals minus 15 plus 16 equals 1. Minus 8 plus 9 equals 1. Yeah, it works. 1 equals 1. We got the right solution. X equals 2. When we stick 2 where x is supposed to be, we get the same, we solve for the equation. All right. There are two special cases that can come up as we're solving these linear equations. The first is illustrated in the next two examples. Notice we start by distributing and moving all the variables to one side. We're going to do this. We're going to do this one after the break.